You're listening to DTFHN for July 7th, 2026. I'm your warranty, voiding host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people argue about things they built instead of things they bought. Today, everything worth having is getting cheaper, smaller, and harder to lock down. Let's get into it. When was the last time you actually owned your router? Not paid for it. Owned it. Knew what firmware was running, could read the source code, could flash it yourself without voiding anything. For most people, the answer is never. You bought a black box, plugged it in, and hoped the manufacturer would keep patching it. They didn't. The OpenWrt project has been solving this problem for over 2 decades, starting as alternate firmware for the Linksys WRT54G. A router so old it could legally rent a car. And now they've done something the networking industry has quietly avoided for years. They built the hardware too. The OpenWrt One is a proper open hardware router. MediaTek Velogic Babelgab 4G, SOAGEM SOK Wi-Fi 6, dual band, 2.5 gig WAN, gigabit LAN, a gig of DDR4, and here's the detail that mattered. A physical no switch on the board, nor flash for recovery. You cannot brick this thing in any permanent way. The schematics are published. The data sheets are public. The bill of materials is open. $106 gets you the complete unit with case and antennas. $84 without. Pull this thread for a second. Every major router manufacturer, Netgear TP-Link is also, ships close firmware that stops getting security patches somewhere between 18 months and never. Your home network's attack surface is defined by a corporation's product lifecycle roadmap. When they decide your hardware is end of life, your security posture becomes their externality. You eat the risk. They move on to the next SKU. The OpenWrt One inverts that entire dynamic. The community maintains the firmware. The hardware is documented well enough that anyone can manufacture it. There's already an OpenWrt 2 in development with Wi-Fi 7. And because this is open hardware running open source, the device's useful life isn't bounded by a quarterly earnings call. The comment section surfaces a practical truth worth noting. Someone mentions they're tired of dealing with the questionable quality of most routers. That's not a niche complaint. That's the mainstream experience. Most consumer networking hardware is designed to be replaced, not maintained. What the OpenWrt project has built here is a proof of concept for something bigger than routers. When you open the hardware and the software, you get a device that improves over time instead of decaying. The community patches faster than corporations. The documentation gets better because users contribute to it. The $100 router you buy today runs better firmware 3 years from now than the day you plugged it in. This is how open source wins. Not by arguing philosophy, but by shipping a board with a recovery switch and publishing the schematics. The tools exist. The price is right. And nobody can turn it off. We talked about owning your hardware. Pause. Now let's talk about owning your maps. CoMaps is offline, first, open source, and completely yours. A commenter in the Hacker News thread puts it plainly. Search on OpenStreetMap-based apps is, quote, incredibly bad. Can't blend city and name. Can't search by category and road. The kind of queries Google Maps handles without thinking about it. And this person wants to switch. They're trying to leave Google Maps. The search won't let them. Follow that complaint to its logical end. Why is search bad on open mapping apps? Because search requires an index. An index requires infrastructure. Infrastructure requires either money or volunteers. Google has 40,000 engineers and a business model built on knowing where you are and what you're looking for. CoMaps has a Codeberg repository and a community that submits pull requests in their spare time. And yet, CoMaps exists. It works offline. It updates your downloaded maps every couple of weeks. It's a fork of Organic Maps, which was itself a fork of Maps.me, which was an open project that got acquired and enshittified. The community looked at that trajectory, said no, and rebuilt. Twice, the genealogy matters. Maps.me proved the concept. Corporate ownership degraded the product. Organic Maps recovered it. When Organic Maps hit governance friction, CoMaps forked again. Each generation inherits the code, sheds the baggage. This is what open source architecture makes possible. The off switch belongs to everyone, which means nobody gets to flip it. Another commenter asks about layer standards. Can I add my own data to these maps? Swimming spots, hiking trails, custom overlays? The answer is OpenStreetMap itself. The protocol is the database. Anyone can contribute locations. Anyone can tag features. The data model is the API. One reply captures the gap honestly. A swimming spot pin on a map isn't useful without photos, descriptions, reviews. User-generated content is what makes Google Maps sticky. That's real. That's a genuine missing piece. But consider what CoMaps already has. Global offline maps. Turn-by-turn navigation. No ads. No tracking. No account required. No server dependency. The entire mapping stack runs on your device from data that volunteers maintain across 190 countries. The search will get better. The layers will come. Open data compounds. Every contributor makes the next contributor's experience slightly better. That feedback loop doesn't have a quarterly earnings call deciding whether to maintain it. The maps are already good. The project is already free. The code is already yours. So what happens when AI models start following that same open playbook? Story 3, GLM 5.2, and the coming AI margin collapse. Every industry has a number it doesn't want you to see. In pharmaceuticals, it's the ratio between manufacturing cost and retail price. Sometimes 40-1. In fashion, it's the markup on raw textiles. In frontier AI, that number is the inference margin, and right now, it's somewhere around 90%. Let me build this up from the economics. Training a frontier model costs hundreds of millions of dollars. That's a fixed cost. You pay it once. Inference, though. The cost of actually running the model when someone sends a prompt. That's the marginal cost. That's the meter running. And when providers charge $25 per million tokens, the actual compute cost is maybe $2 or $3 of that. The rest is margin. The entire business model of frontier labs is spend enormous sums training, then amortize that investment across oceans of very profitable inference. This works beautifully. Until someone releases a model that's just as good and lets you run it yourself. GLM 5.0 from Z.AI appears to be that model. Martin Alderson, who's been using it daily for weeks, says he genuinely struggles to tell the difference between it and Opus. It has real weaknesses. No vision support, sluggish thinking tokens, mediocre web search through MCP. These are legitimate gaps. But the core capability, the raw intelligence of the model, is at the frontier. Think of it like brewing. For decades, a handful of massive breweries controlled the market. The equipment was expensive, distribution was locked up, and the margins were extraordinary. Then homebrewing equipment got good enough. Not perfect. You couldn't match every style. You couldn't distribute nationally. You needed some expertise. But the beer itself, the beer was genuinely excellent. And once the beer is excellent, the 90% margin on the commercial product starts looking less like a business model and more like a countdown timer. One commenter nails the counter-argument. Compute cats collapse with cloud computing and hyperscalers still have fat margins. True, but cloud providers sell infrastructure. AI labs sell intelligence. And intelligence, unlike a server rack, can be copied at the cost of a model download. The gaps in OpenWrt's models are real and they're shrinking fast. Vision will come. Tool calling will improve. Web search will get solved. These are engineering problems, not fundamental limitations. Meanwhile, the core product, the thinking itself, is already competitive. What GLM5B represents isn't just another open model. It's the proof that the margin structure of frontier AI is temporary. The inference profits funding those billion-dollar training runs are about to face real pressure from models anyone can deploy on their own hardware. The training costs stay high. The inference premium evaporates. The tools exist. The weights are available. The margin collapse isn't a threat to AI. It's a threat to AI gatekeeping. And that's exactly how this is supposed to go. Now for something completely different, and I mean that literally. Story 4 takes us from silicon to concrete, from inference costs to ocean waves. 30 tons of concrete, shaped like a letter H that got twisted in a bar fight. That's a Dolosse. And if you've ever walked along a harbor wall anywhere from Cape Town to Tokyo, you've probably stepped over hundreds of them without knowing you were looking at one of the most elegant pieces of civil engineering ever devised. This shape looks almost random, like someone dropped a piece of rebar and it hardened mid-bounce. But that apparent randomness is the entire point. When you stack rectangular concrete blocks against the ocean, waves hit them like a battering ram. All that energy concentrated on flat surfaces, shoving and grinding until the wall fails. Dolosse do something different. Their interlocking arms tangle together like a pile of enormous jacks, creating a porous, flexible armor that lets water flow through and around each unit. The wave's energy doesn't bounce back or concentrate. It dissipates. The ocean punches and the Dolosse just opens its hand. Port Elizabeth's Kawaga Deepwater Harbor uses almost 30,000 of them, each one 30 tons, forming a 2.5-kilometer breakwater. They can be placed randomly or stacked with precision. Either way, the geometry does the work, and they stay put in conditions that would scatter conventional blocks like dice. The origin story is bootstrapism. A South African engineer working for the railway and harbour services in East London designed the shape in 1963. The name comes from Afrikaans, likely inspired by knuckle bones. Those small ankle bones kids have used in games for centuries across southern Africa. The inventor received no payment. No patent was filed because the work belonged to the state. The design spread worldwide precisely because nobody owned it. Japan, Europe, the Middle East. Coastlines everywhere are armored with a shape that exists in the public domain, because a government employee's contract said the idea wasn't his to keep. The comments on this one are worth noting. Several readers point out that the photo in the article actually shows tetrapods, not Dolosse. A different concrete armor unit with 4 legs instead of the twisted H shape. There's a whole taxonomy of these things, and the Wikipedia rabbit hole on wave-dissipating concrete blocks is genuinely delightful. What makes Dolosse worth celebrating isn't just the engineering, it's that the design traveled freely. No licensing fees, no proprietary lock-in, a shape born from watching children play with bones, refined by an engineer who never got rich from it, now protecting harbors on every continent. The tools exist. The geometry is available. The ocean doesn't care who holds the patent. Open designs protecting coastlines. Open protocols decoding genomes. Story 5. Sequencing your own DNA at home. $7,500. That's what the sequencer costs. The Oxford Nanopore Minion. But that number isn't the one that matters. The one that matters is 5. This person has sequenced their own genome 5 times. At home. With a cheek swab, a used centrifuge from eBay, and a heat block that costs less than a decent pair of headphones. Let's break this down to what's actually happening. You swab the inside of your cheek. You list the cells, meaning you break them open to get at the DNA inside. You clean it up, attach adapters so the sequencer can grab onto the strands. And then you feed those strands through a nanopore, a literal hole in a membrane, while electrical current measures each base as it passes through. Adenine, thymine, guanine, cytosine. Your source code readout, one letter at a time, in your kitchen. The raw output isn't a diagnosis. It's a reference layer, a VCF file, a variant call format, listing every place your genome differs from the human reference. Then you query it. Tools like ClinVar cross-reference your variants against known clinical significance. PharmGKB tells you whether you metabolize certain drugs faster or slower than expected. That's not theoretical. That's the kind of information that changes what your doctor prescribes. One of the commenters raises the privacy question that deserves a straight answer. Why sequence at home for privacy, then upload the results to a cloud model? And that tension is real. But here's what's different about this setup versus mailing a spit tube to a company. You hold the raw data. You choose what to share, with whom, and when. The sequencing itself is sovereign. What you do with the output is a series of decisions you get to make, not terms of service you get to accept. The costs are still steep. The consumables alone run over $1,500 per high-quality run. The commenter who's done wet lab work is right that you will fail, probably multiple times. This is not plug and play, but strip away the current price tags and failure rates and look at the trajectory. Sequencing costs have dropped faster than Moore's Law for 2 decades. The minion fits in your hand. The reagent kits ship to your door. The analysis tools are open. The models are getting better at interpreting variants every month. What's happening here is the same thing that happened with computing, with publishing, with manufacturing. The tools move from institutions to individuals. The expertise follows. And then interesting things happen, because 1,000 curious people asking questions about their own biology will find things that no centralized research program would think to look for. The genome isn't magic, but owning your own data, running your own queries, making your own decisions about what to investigate and what to share, that's infrastructure for a kind of medicine that doesn't exist yet, and someone is building it on their kitchen counter. But what happens when the infrastructure itself isn't reliable? When the network drops and you still need intelligence at the edge? I once spent 3 days debugging a system that worked flawlessly in staging and completely fell apart in production. The culprit wasn't code, it was latency. A round trip to a server 12 time zones away. Through infrastructure that looked great on a network diagram and terrible on an actual wire in an actual country. That experience rewired how I think about where computation should live. Adebayo Long learned the same lesson in a Cape Town hotel room in 2019. He built RX Scanner, a handheld spectrometer that scans pills with infrared light and checks their molecular profile against a pharmaceutical database. Counterfeit medication kills thousands of people across Africa every year. And this device catches fakes in seconds. Except that morning, it didn't. The AI model lived in a U.S. data center, 14,000 kilometers away. A single scan took 5 minutes over limited bandwidth. His engineers shrunk the model to run on an Android phone in 2 hours. No server, no broadband, no data center. Just the device in your hand and an answer you can trust. Now, apply the architecture test. The original system was closed by design, even if unintentionally. It required a persistent connection to infrastructure controlled by someone else, hosted on another continent. The moment bandwidth dropped, the system failed, and people who needed to verify their medication simply couldn't. The rebuilt version is closed loop in the best sense. The intelligence lives on the device. The pharmacist in rural Nigeria has the same capability as the one in Lagos. This pattern is showing up everywhere. Drones in India identifying disease cashew plants with onboard processing. Arduino devices running electrocardiograms in parts of Brazil where hospitals are hours away. Tiny models trained on specific problems deployed on hardware that costs less than a textbook. A professor in Brazil named Marcelo Rovai, who's worked on projects from malaria mosquito detection to vineyard pest identification, calls this the most important area in AI right now. I'd go further. This is where AI actually earns the word intelligence. Not by getting bigger, but by getting useful where it's needed most. The World Bank says 0.7% of internet users in the poorest countries have touched ChatGPT. The frontier model conversation is irrelevant to most of the planet. What matters is whether a farmer can check her crops, whether a pharmacist can verify a pill, whether a nurse can run a cardiac screening. And for that, you don't need a billion parameters. You need the right 50 million, running on hardware that fits in a pocket and works when the power flickers. The tools exist. They're small enough to carry. Now shift gears entirely from tools that fit in a pocket to a company trying to fit your entire digital life into a tracking number. In 1995, Intel shipped the Pentium 3 with a processor serial number, a unique identifier baked into the silicon that could be read by any software. The privacy backlash was immediate and ferocious. Intel eventually disabled it by default. The lesson seemed clear. Don't give every machine a fingerprint that follows it around the internet. Microsoft apparently learned a different lesson. Don't tell anyone you're doing it. A 19-year-old alleged member of Scattered Spider got extradited because Microsoft matched his Windows installation's global device ID to his browsing activity across third-party services. The GDID is a persistent identifier tied to your Windows install that tracks which sites you visit when you visit them, and from where. Even through a VPN, the FBI's criminal complaint lays it out with the quiet precision of a receipt. On May 12, 2025, at 1921 UTC, this device ID accessed ROC's sign-up page. Then, it accessed multiple sites from these hosting servers. Here is the teenager, here's the arrest. Now run this forward. 3 billion devices run Windows. Each one has a GDID that persists across every operating system update and resets only on a full reinstall, which Microsoft can almost certainly relink through your account, login, or hardware identifiers anyway. That is not a device management feature. That is an infrastructure-scale surveillance capability sitting in the terms of service nobody reads. The comedy is in the geometry. Microsoft spent years building a tracking apparatus into its closed operating system, and the moment it becomes public isn't a transparency report or a privacy audit. It's a criminal complaint against a teenager. The architecture was always there. The only question was who'd notice first, privacy advocates or federal prosecutors. Prosecutors won. One commenter nails it. My surprise level is at approximately 0. The fix is the same fix it's always been. The operating system you can't audit is the operating system you can't trust. The one you can read is the one that can't hide this from you. Moving on. The strongest argument against this project is obvious. You're handing a child a pen, connecting it to a large language model running as root on a device with no content filter, and wrapping the entire thing in the aesthetic of a fictional artifact that literally possessed people. One commenter points this out directly. Tom Riddle's diary manipulated a child into opening the Chamber of Secrets. The branding is, at minimum, unfortunate. Now let me explain why that argument collapses under its own weight. Maxime Rivis built Riddle in Rust. It reads raw pen input at hardware event rates, 4,096 levels of pressure, commits the page as a PNG after 2.8 seconds of idle, sends it to a vision model, and renders the response back as animated handwriting. The reply appears stroke by stroke in dancing script, skeletonized down to single pixel pen paths using Jiangsuan thinning, then fades. The entire pipeline. Pen capture, ink surface, handwriting scenes, over actual process manager, to display backend. Ships as open source under a license you can read in 30 seconds. The takeover display mode stops the vendor UI entirely and drives the e-ink engine directly for minimum latency. A gene constructor interposition shim over Remarkable's proprietary waveform library, exposed as 3C functions. Quill init, quill buffer, quill swap. That is not a weekend hack. That is someone reverse engineering a closed hardware stack and publishing the result so anyone else can build. The content filtering question answers itself once you look at the architecture. The Oracle backend is configurable. Point it at OpenAI OpenWrt GRU, a local model on your own hardware. The API key is yours. The system prompt is yours. The code is yours. You are the one who decides what the diary says. Compare this to every locked-down tablet marketed to children where the filtering decisions happen on someone else's server, under someone else's terms of service, subject to change without notice. A parent worried about what the diary might say can read every line of code that produces the response. A parent worried about what a proprietary kid's tablet might say cannot. The open system is the safe system. It has always been the safe system. Rivis built a magic diary and then showed everyone exactly how the magic works. That is the opposite of a Horcrux. We've been talking a lot about what runs locally today. Story 9 takes that idea and shrinks it down to 7 megabytes. What happens when a capability that used to require a server, an API key, and a monthly bill just disappears into the browser tab you already have open? This is the trajectory that matters. In 1993, NCSA Mosaic shipped inline images. Before that, viewing a picture on the internet meant downloading it separately, opening a dedicated viewer. Mosaic didn't invent images. It eliminated the seam, and eliminating seams is how technologies go from specialist tools to universal infrastructure. Ternlight is a seam disappearing. It's a sentence embedding model. The kind of thing that powers semantic search, recommendation engines, document clustering, compressed into 7 megabytes. 5 if you use the mini variant. It runs in your browser via WebAssembly. Embeddings generate in about 5 milliseconds on a CPU. 3 lines of JavaScript. 1. npm install. No model download step. No server. No API key. No billing dashboard. The engineering here deserves attention. The creator distilled a sentence encoder from mini-LM using ternary quantization-aware training, then wrote a custom inference engine from scratch. Ternary quantization means the weights are -1, 0, or 1, 3 values. That's where the name comes from. This brutal constraint is what makes 7 megabytes possible, and the craft is in making those 3 values do useful work. Pull this thread forward. A developer building a recipe site drops in Ternlight, and suddenly users can search by meaning instead of keywords. Entirely client-side, no data leaves the browser, no inference cost on the server, no privacy policy needed for the search feature because there's nothing to disclose. One commenter nailed it. Lazy load embeddings at build time and ship semantic search as a static site feature. The capability just folds into the stack and vanishes, like inline images in '93. The seam closes and nobody remembers it was ever there. That's intelligence disappearing into infrastructure. Now, let's talk about how intelligence organizes itself inside the model. One commenter cut straight through the framing. The JSpace, they said, is basically a measure of how much tweaking and internal activation would change the final output. That's it, a sensitivity analysis. And they're right. Mathematically, that is what the Jacobian measures, but what Anthropic actually found with that measurement is where this gets worth your time. They discovered that Claude has developed, on its own, without anyone designing it, a small set of internal representations that behave like a shared workspace. When Claude solves a multi-step problem silently, the intermediate answers light up in this space, even though it never writes them down. You can ask Claude what it's thinking, and it'll report what's active in the JSpace. You can ask it to think about France, and France activates there. And from that single activation, it can pull the capital, the currency, the continent, flexible, general purpose, broadcast to the whole network. The question nobody in the comments wanted to sit with. Is this consciousness? Anthropic is careful to say no. But here's the question underneath that question. If a system independently develops Omega's functional architecture that maps onto the leading neuroscience theory of conscious access, global workspace theory, what exactly is the meaningful difference? Not whether it feels like something, whether the engineering distinction holds. And this research is published openly. The methodology, the probing techniques, the independent commentary paper linked right alongside it. This is what interpretability looks like when you actually want other people to verify your work. The tools to examine these systems exist, and Anthropic just handed them out. This has been your daily tech feed for Hacker News for July 7th, 2026. This podcast is entirely AI-generated. Scripts by Claude Sonnet 4.7. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that belongs to you. We'll see you back here tomorrow.